Hello and welcome. Today we are going to solve 7th problem in a series of 8 problems of JEE Advanced 2020 Paper 1. The statement of the problem is a bit lengthy. Let me read it out for you. For a polynomial gx with real coefficients, let mg denote the number of distinct real roots of gx. Suppose S is the set of polynomials with real coefficients defined by S is equal to x square minus 1 whole square into a0 plus a1x plus a2x square plus a3x cube. For a polynomial f, let f dash and f double dash denotes its first and second order derivatives respectively. And we are asked to find the minimum possible value of mf dash plus mf double dash, where f belongs to S. We are given the set S of polynomials of the form fx is equal to x square minus 1 whole square into px for some polynomial px having degree 3 or less. Notice that the coefficient of px are not necessarily non-zero, so the degree of px can be less than 3. We need to find the minimum possible value of mf dash plus mf double dash. In other words, we need to find the minimum possible value of the sum of the number of distinct roots of f dash and the number of distinct roots of f double dash. First, we try to find the minimum possible value of mf dash. We notice that minus 1 and 1 are the roots of fx with multiplicity at least 2. Therefore, minus 1 and 1 are the roots of f dash x. To see this, we can simply find f dash x. We get it in the form x plus 1 into x minus 1 into qx for some polynomial qx. This shows that negative 1 and 1 are the roots of f dash x. From this point, can we conclude that the minimum number of distinct roots of f dash x is 2? The answer is no. Here is a catch. Since negative 1 and 1 are the roots of f dash x, so by Rolle's theorem, there exists at least one root between negative 1 and 1. It means no matter what px is, the number of roots of f dash x is at least 3. This shows mf dash is at least 3. Let's move ahead to investigate f double dash x. Since there are at least 3 distinct roots of f dash x, so by Rolle's theorem, there must be at least 2 distinct real roots of f double dash x. So we conclude that the minimum value of mf dash plus mf double dash cannot be less than 3 plus 2, that is 5. But can we obtain minimum value 5? We claim yes. But in order to approve this claim, we have to supply some function fx which confirms the claim. We simply let the polynomial px be a constant polynomial 1. So we get fx is equal to x square minus 1 whole square. And when we do calculations with this fx, we find the number of distinct real roots of f dash x is 3 and of f double dash x is 2. This proves our claim and the answer to the problem is 5. This completes the solution. This was an excellent problem involving Rolle's theorem and the fact that the roots of order 2 or more of some polynomial are also the roots of its derivative. Plus, we carefully noticed that the coefficients of px need not to be non-zero. This simple observation helped us to find an example of fx which demonstrated that 5 can be the minimum possible value of mf dash plus mf double dash. That's it in this video. In the next video, we shall solve an excellent problem based on the limits. Needless to say, try yourself before watching the solution. Thanks for watching the video. See you next time.